First of all, thanks everyone for attending, for signing up and coming. I'm excited to have you all here with us and to go through these new resilience guidelines and worksheet tool in the B3 program. We have a overview here. We'll go through a couple logistics and housekeeping items. And Richard will give us an introduction to resilience and the built environment. And I'll go through resilience in B3, a new and additional guidelines, and then the worksheet walkthrough, and then we'll have some time for questions and discussion at the end. This webinar is being recorded, so it will be available on our YouTube channel page and linked via our training and education page on the guidelines that is listed there. We have all the attendees on mute. And we would encourage you to use the question and answer function or the chat function during the presentation. We'll hand off monitoring that while the other one is talking. So chat in your questions at any time and we'll either address them all at the end, or if they're time sensitive, we'll get to them sooner. For AIA credit, please enter your number in the chat if you hadn't given it to us previously on this registration. And then all attendees will be emailed a certificate at the end of the webinar for other certification purposes. All right, and then also with that certificate will come a survey about the training experience, and then the slide deck that we'll be presenting today will also be sent out immediately after or shortly after. All right, and then I'm gonna start closed captioning this as of now. So bottom to hide it or disable it, so you guys can find that button there. Turn off mine because it'll be distracting. So that's just for access reasons or for future reference, but closed captioning will be on for this. Some general B3 updates. The small buildings method is coming soon. We're in the finalizing of that document writing right now. The text will be available on our website in the next couple months. And then we do have an upcoming training session on that on March 18th at 10 a.m. And the link is there, and I will also drop it in the chat here in a moment. And then in April, we'll be having our Best of B3 virtual recognition event. This is to honor our B3 projects that have met excellence in design and performance. And that will be hosted and coordinated by LHB, and invitations will be coming out soon for that. So look out for that in your inboxes. And I'll hand it over to Richard now. Thank you.
Great, thanks, Liz. And so briefly, I just want to give a bit of a history of our thinking in integrating resilience into the B3 guidelines. And some of this early work, Laura Milberg from MPCA, I see she's one of the attendees. She was very gracious to help fund early research into how can we integrate B3 resilience into the B3 guidelines, because we wanted to think about a system that does both sustainability and resilience. Because we feel it's important for design teams and owners to be integrating both things at once, instead of having one set of guidelines for sustainability and a separate set of guidelines for resilience. Why can't they be the same thing? And so our initial thinking in terms of how to integrate the two was to take some of our thinking about regenerative design and how that is influencing our updates to B3 in the sustainability program. And if we're achieving regenerative design, and I'll get more into this in a minute, that ought to be a bridge between sustainability and resilience. And it's thinking about things like, this is a photo from the hurricanes in Puerto Rico, where you see Tesla delivering solar panels to a children's hospital to get it back online when the grid was down. And one of the ideas about regenerative design is, do you not only have renewable supply to things, but you integrate storage with that, which is what happens in nature. And so in this case, with the solar plus the batteries, Tesla had this hospital back up and running months before the grid was restored. Next slide. The other thing with B3 we found is we have pretty much every building type, almost every building type in B3, except for hospitals. So it's a good test bed for if we're trying different sustainability strategies or resilience strategies as it's executed on various size projects in different parts of the state and different project types. It ought to help teach us some things that we can learn about sort of the broader built environment. Next slide. And so to kind of talk about regenerative thinking and how that was became a bridge between sustainability and resilience. This is a slide that shows kind of our typical approach to green buildings, where we just think of one-way sources of the supply of things like energy and water and materials. And often we just think about efficiency measures. Let's be more energy efficient. Let's mitigate waste outputs, et cetera, as sort of the traditional approach. Next slide. A regenerative approach tries to think of the built environment as a living system. So we have sources of things, energy, water, materials, et cetera. We think about them being redistributed in the built environment. We integrate storage because there might be times when we can generate energy from solar panels, but that probably will be different when we might be using that energy. So we need to integrate storage to align generating things and usage of things. And then there really is no waste. Waste is the goal is that waste is food for another process as it's assimilated back into the environment. So next slide. So what we decided to do kind of in our early testing, we set up two project types, multifamily housing project, a library project that was designed to meet the SB 2030 80% better. So very energy efficient projects and integrating solar to be net zero buildings. And what we looked at doing, and we took a tabletop exercise from a group in the federal government that was a working group of the Department of Energy, EPA, and Department of Defense, where they did tests of military bases against different shocks. And we took these two building types and we exposed them to three shocks, basically, disconnecting them from the grid for 10 days, disconnecting them from water supply and wastewater removal for 10 days, and disconnecting them from vehicle transport for 10 days. Ran these sort of net zero energy and sustainable buildings through this, looked at what it would take to, what redesign measures we would need to take so that it could meet these shock requirements, redesign the buildings, and ran them through the tests again. Next slide. We also looked at, as we did all this testing, we also, with future climate files from Climate Shift, we incorporated, future climate scenarios from the IPCC fifth assessment, so that we could not only think about these shocks, but also do it using future weather files in future conditions as we ran various energy models of these buildings to see if there were things that we needed to be factoring in with future weather as we started to do some of this resilience testing. Next slide. And what's interesting, what we found in some of these files were that if you look, this graph shows various strategies that can be incorporated. So the on the left are a series of strategies that can be used to bring a building into comfort, and it shows in hours in the various columns the number of hours that are comfortable, number of hours that say sun shading will make the building comfortable, and the current climate file, and then predictions out in 2030 and 2040. And what you see next slide that's interesting is as the climate changes and we get hotter and more humid summers, things like cooling needs almost double in the amount of hours. Sun shading, which may not have needed to be a strategy in the past, becomes more of a strategy as we have these kind of hot, humid summers. Next slide. We also found, some of the things that we were already doing in SB 2030 in high performance buildings, like having improved building envelopes with more insulation on the roof and better walls and better windows. We're already starting to do good things like isolating the interior environment of these high performance buildings from the climate changes going on outside. So that if you look at things like, these buildings designed to, old energy code versions and then the optimized version, they're using a lot less energy over time. And actually there isn't significant amounts of performance differences with the, with the new climate files, because they are so much better insulated to mitigate some of these changes. And this was true for the multifamily building, and next slide, and also the library building over time. Next slide. So here's an example of one of those prototypes. This is the multifamily building that, again, high performance envelope, integrates solar on the roof. Solar is integrated with energy storage as well, and other kind of demand reduction things are integrated in. And also these strategies also allow you to island off the building if needed when the grid goes down, and the solar can be supplying energy usage in the building, and also the batteries can be serving that usage at night and over time. Next slide. So what we found, what was interesting is what we found in the multifamily building. We started to think about different operating modes, that there's standard operations and that energy usage, but if an event or disruption happened, you would kick the building into shelter in place mode that would dramatically reduce energy usage, focus on things like emergency lighting, running refrigeration, and things like that. And what's interesting, this is a building type that is dense enough that you actually couldn't get it to net zero energy with just the solar on the roof. However, and if you go to the next slide, so in the standard operating, you couldn't get it to be net zero with just the solar on the roof over the course of the year, which has traditionally been the approach to net zero for sustainability. But when the demand is reduced to shelter in place, you can get the usage low enough so as the batteries are drained overnight and you get into the next day and the solar generates, recharges the battery, and then runs the building over time, you actually can very easily meet the 10 days of disruption by recharging batteries and lowering that usage over time. Next slide. And then, the same holds true for water. Storage strategies, again, are integrated in with rainwater collection, gray water storage, and that allows you to have the building disconnected from water supply and wastewater removal for a period of time, and you can still flush toilets for sanitation and things like that. Next slide. So the library building type, many of the same strategies again, solar plus storage, similar water strategies, etc. Next slide. Similar water strategies. The library building type is interesting to think about, and we started to think of it as a disaster hub or a resilience hub, because if you took building types like libraries, like rec centers, like neighborhood schools, most people live within 1 mile of these building types in the Twin Cities and many other cities around the state. And what's interesting, if you go to the next slide, if you take an example library, this is the library in Highland Park in St. Paul, and you think about how many people live within a half mile of a building like that, we started to think of, well, what if you took 10% of the population in that catchment area, and if there was a disruption, let's imagine some percentage of those homes might be damaged, so they don't have access to power or water or food or what have you, and they need to relocate to one of these resilience hubs. So, next slide. So in this case, different from the multifamily building, the alternate operation mode becomes kind of emergency mode, where energy usage increases because people are charging phones, they're you adding refrigeration maybe, so people have access and can keep medicines cool. Emergency service folks might be treating people here. So the idea is that this becomes kind of a hub of increased energy usage to take care of people's needs. Next slide. So in this case, what's interesting is, again, energy usage goes up. This is a building type that isn't as dense. It has a lot of roof area for the amount of occupancy. So it's a building type that would be fairly easy to achieve net zero with solar on the roof. In fact, you wouldn't even need to cover the entire roof with solar panels. But when you start to think of an operating mode as a resilience hub, maybe you increase the amount of solar on the roof so that you can recharge more batteries and take care of a larger need in case a disruption occurs, and that becomes a key element of a neighborhood resilience strategy in this case. So next slide. So you can see I think this just gives you a little bit of kind of context of our system thinking as we started to, through this research, identify ways that we could add new guidelines to B3, appreciate that current guidelines we might have in B3 are contributing to resilience. And we use this idea of a regenerative system, having a building replicate a regenerative system as this sort of bridge to resilience. What also became, and Liz really spearheaded this idea, if you go to the next slide, it's important to not only just think of the regenerative goals in the big picture system redesign, goals like, well, if we can make it so these buildings have renewable supply and they can be islandable, and if the grid is unpredictable, that gives us continuity of power, and then it allows certain macro strategies to occur in these buildings types to maintain habitable temperatures, operate in low power modes, store energy. And then in order to achieve those macro strategies, it then kind of takes you to micro strategies and technologies that you need to start to think about to integrate them into the building design to make it capable of achieving some of these resilient benefits. And that has been kind of the foundation of thinking how to transition some of these things into the B3 guidelines. Next slide.
All right, great. Thank you, Richard. That was a wonderful overview and great linking of our research to the guideline development. And I'll touch on that again in a little bit more. So just a reminder for the overview of this section, specifically about resilience in B3. I'll talk quickly about the timeline for development and implementation of these guidelines. I'll describe our new guideline in the performance management section, a couple additions to existing guidelines, highlight some of the resilience co-benefits from other existing guidelines in B3, a quick comparison of other green building programs' approach to resilience with a focus on LEED and their pilot credits. And then we'll do the worksheet walkthrough. And that's when you guys can feel free to open up the worksheet that was sent to you and follow along and contribute to the chat or to the questions as we get through that, because I'd love to hear how it's going and what kind of results you guys are getting. So the kind of quick timeline of the resilience in B3 is, as Richard mentioned, we started looking at resilience and sustainability as part of regenerative design in the project funded by the MPCA, also that Richard mentioned. And the link to that is here. I'll drop it in the chat as well. And after that work, we started our initial review of resilience within B3 and identification of the opportunities and gaps therein. So we started developing the guideline and the worksheet tool. In March of 2020, we had an expert working group convened to review our process at that point. And again, thanks to Laura Milberg for participating in that, especially, and Kenny Blumenfeld and Terry Zine for all those great resources and references and reactions. And then that was actually my last in-person meeting before before everything went remote. So that was a good one to go out on, I think. In November of 2020, we presented the preliminary strategy of the guidelines and how they could relate to some buildings at the AIA Minnesota Conference on Architecture. March 2021, the resilience guidelines will be going live as recommended measures as part of guidelines version 3.2 revision 1, which will also include that small buildings update that I mentioned. So because we're mid version, we didn't want to make these required guidelines, but we also didn't want to wait until we did require them to have them out and available for people to explore. So for now, they're recommended measures and will be supported by the website and the tool. And then our plan is that next year, in the next version of the B3 guidelines, they will be required. So as I mentioned, there is one new guideline in the performance management section, the P guidelines, and it will be P3, vulnerability and capacity assessment and resilience planning. So the intent of that is to bring awareness and intention to the functionality and role of the project in the event of a disruption. And similar to what Richard described, our general approach is that the resilience is viewed through the lens of the goal and then the steps needed to reach that goal and the goal of the response. So it's not tied to a specific hazard or risk, but more a consideration of the response to any possible disruptions. So the, as of now, recommended, eventually will be required performance criteria are to use that B3 worksheet that we'll be going through to assess the natural and human-made hazards at the site scale and building scale, assess the project attributes that could be benefits or detriments to the building, things like building systems, and then establish that resilient goal that we mentioned, and then identify the strategies that will enable the building to achieve that goal, like the physical things that need to be designed and installed in the building to make it happen, and then to actually do it. So do the assessment, identify the strategy, and then actually integrate and implement at least one design strategy to mitigate an event. And then if necessary, provide documentation and information to the end users to use those resilient design features. You know, if it's something like a low power mode that needs to be switched over in the building automation system, that should be clearly outlined for people who will be in the building at the disaster event, should it occur. And then, of course, you're free to integrate and implement additional design strategies as part of this guideline. So we'll be getting back to this tool, as I keep saying, but quickly, it's an Excel-based worksheet tool that references several websites. It has some preloaded data at the county level from both the Minnesota State Hazard Mitigation Plan, which was updated and released in 2019. It's developed by the Department of Public Safety's Homeland Security and Emergency Management Division and approved by FEMA. And it includes a county level survey of the history and possible future of natural hazards across the state. And then also the FEMA National Risk Index, which I believe was rolled out in 2020, but I was made aware of it just at the beginning of this year, which is an online mapping application that identifies community risk to 18 natural hazards and includes data about expected annual losses, social vulnerabilities, and community resilience. So those two data sources make up a lot of the natural hazard assessment, and then the human-made hazards are more based on discussion and interpretation, just because there's less data backing those to draw from. And then, as I mentioned, the system assessment and goal setting and the resilient design strategy bank. Some of those design strategies are sourced from the following here that we can see here, the Urban Sustainability Directors Network, Guide to Developing Resilience Hubs, the RELY guidelines and the LEED pilot credits, Enterprise Green Communities, Strategies for Multifamily Building Resilience, a study from the University of Michigan about green building and climate resilience, and then the Fortified Standards, which is a voluntary program administered by the Insurance Institute for Business and Home Safety, including design details and material requirements. So there are also some additions to existing guideline areas, one of which is in addition to E1, energy efficiency. So this recommended performance criteria would be to use the SB 2030 as design tool, the web-based modeling tool, to assess the building energy model in future weather data that will be provided by B3. So we'll have, I think the plan is to have representative files for areas of the state that teams can access with the SB 2030 as design tool. And we're still working out some of the details of how that will work, but hopefully an update in the tool to come. So the future weather may impact sizing, energy demand, or other aspects, as we saw with some of the earlier slides. And then we asked that if there are impacts that would change the building significantly within its service life, that those be addressed in the design process. Another additional one is to I4, which is thermal comfort. So the basic concept here is of passive survivability, and that would be that the building can maintain a thermally safe, not necessarily comfortable, but thermally safe conditions during a power outage lasting 4 days during representative extreme conditions. So that has a lot to do with the insulation of the building and the way it holds on to heat or cool throughout time. So that can be simulated with energy modeling, and that's what we would want to see for that requirement. And then finally, there's a couple additions to the environmentally preferred materials category around, one is about impact of windborne debris in hurricanes, and that standard is written for hurricanes, but applies to all kind of windborne events. So if the building is in a high risk area of windstorm or hail or tornadoes, that would be perhaps a requirement. And then similarly, meeting a voluntary standard for security impact in areas with a high risk of perhaps civil disobedience or similar. And then just to consider the expanding termite range in the United States when specifying materials and detailing foundation systems. Termite ranges are expanding every year. So, and we have some resources for the termite things in the guidelines when those go live. I see a question about the weather files that I'm going to answer real quick here. So the question is, how far out are the future weather files, and is there a standard projection for planning? So the files we have used so far, one was representative of 2030 and one was representative of 2040. And it's kind of an open question how far out we would project with the as design tool, and relates to how available that data is. We're certainly open to ideas or responses about that. And I know that there's some action at the state level to get the climate modeling done and available. So for now, we're looking at least 20 years out with a potential to look further out. And we are assuming that the RCP 8.5, which is the worst case scenario in IPCC 5, will be the scenario. So I hope that answers your question. And if it doesn't, feel free to write in again. Thank you. And I mentioned there were some existing resilience benefits in the B3 guidelines. So I'll go through those kind of quickly here. Site and water guidelines have a lot to do with obviously the connection to the site and to the larger community. The focus on human system connections is helpful in those times when transportation may not be available or accessible. Site water quality and efficiency can do a lot of work to protect the building from water intrusion. And of course, our base requirement that you're not allowed to build in a FEMA floodplain unless essential to the project, and then additional flood mitigation strategies are required. And then we have a general guideline to reduce potable water use in the building, which of course would decrease the need for storing or treating potable water in the event that a disruption occurred to the municipal supply. Our soil management and erosion similar to the water quality and efficiency guidelines, make sure that the building and site are protected from flooding events, and that the structural integrity of the building is maintained, as well as the underground services that are provided via municipal lines. And then again, sustainable vegetation design works to stabilize the soil and treat the water. And then a site albedo, a lower site albedo may contribute to larger resilience of the area by mitigating extreme day and night temperatures. All right, and then in our energy and atmosphere section, the energy efficiency guideline, which will have that added future looking energy file requirement. Of course, meeting the SB 2030 energy standard ensures the building uses energy efficiently all the time, and then the critical load needed to operate the building in any mode is therefore lower. And similarly, the provision of renewable energy ensures some redundancy in the power supply system if it's wired to go directly to the building, and designing to be renewable ready opens the possibility that in the future, when solar costs come down more, that non-financially feasible projects now could become financially feasible later. And of course, we have a current recommended measure for a resilient power infrastructure, including a battery or permanently installed generator, or a quick connect for a temporary generator. And similarly to the other reductions in energy demand goals, the efficient equipment and appliances can reduce the critical load and maintain more operation during a reduced power situation. You know, more energy store refrigerators could be on than regular ones. In the environmental quality section, the moisture and water control guideline has a lot to do with the structural durability and resilience of the project, making sure that the construction maintains its integrity as designed throughout the project life, and then that air and water are controlled in that envelope. And then the I4 thermal comfort is the one that has that additional recommended guideline for passive thermal comfort, or for passive survivability. And that goes one step beyond this passive thermal comfort. This guideline is a kind of first step towards that that passive survivability measure. And lighting and daylighting, again, reduces the ongoing operational energy and critical load demands, and then could be useful for passive solar heating in the event of an outage in the winter hours. And then the recommended measure of high reflectance surfaces also increase daylight utilization and further reduce energy use. Finally, in the indoor environmental quality, the ergonomics and physical activity measures to provide shower and changing facilities could become very useful in a resilient situation where people maybe are spending extended time in the building that they wouldn't normally, and having those extra resources could be very useful. And then again, locating it near services in the event of a transportation disruption, if that's allowable on the site. And then the interior wayfinding and universal access measures, I think, are extremely crucial to any resilience hub type of project, because that goal is based on the idea that people will be coming to the building who may not ever go there again or before or again. So that the wayfinding should be clear and easily understood, and that it should be universally accessible to all abilities and ages, so that those universal design principles should be implemented throughout. The materials and waste guidelines have, again, some considerations of durability to make sure that building materials will endure or be replaceable during the building's life. And then to address partial or total deconstruction if there is an event of significant damage, if part of the structure could be either reused in place or salvaged and reused elsewhere. And the health guidelines in general, asked to demonstrate a reduction of likely hazardous materials to protect occupant health. And in the consideration of resilience, there may be extended occupancy or higher than design occupancy. And there may also be situations where materials get waterlogged or burn. And so there's some considerations of health impacts for those as well. All right, so. And I see a follow-up question here about the future weather files, asking, should the expected life of the building determine how far out the future weather files go? And in my opinion, absolutely. I think we expect B3 buildings to last at least 50 years, if not longer. So in my opinion, the future weather files would go at least that far. And then also a comment about rising groundwater levels due to increased precipitation may also be an issue for some sites, and agree that incidental flooding is a hot issue and to my research, hard to pin down. So we certainly welcome any resources or information on that kind of topic. All right, so to get into the LEED requirements real quick. So LEED has 3 different pilot credits, all of which would contribute to the innovation credit in a LEED project. So they're worth a couple points in that innovation category. And you'll see that they are very similar to our options, or to our guidelines, which are also, optional or recommended as of now. So the first one is IPPC 98, Assessment and Planning for Resilience. The intent is similar to ours, is to encourage people to think about it before they start designing, basically. And the requirements are similar as well. The hazard assessment associated for risks associated with natural hazards, and then site-specific hazards with client knowledge. And then either to complete a climate-related risk management plan or to complete an emergency preparedness plan based on a specific Red Cross form and process. The next one is IPPC 99, which is designed for enhanced resilience. And this is equivalent to the second part of our guideline, where you take the results of that assessment, the hazard assessment, and implement mitigation strategies to deal with it. And so LEED asks you to identify 2 of the 3 top hazards and then implement mitigation strategies based on the guidelines listed. So these are the hazards and the guidelines that LEED considers. And we did use a lot of the same guidelines and standards. You can see the fortified here that I mentioned earlier, and of course RELY. And then the final one, also similar to our recommended guideline, is passive survivability and backup power during disruptions. The intent is to make sure that the buildings maintain the same thermally safe conditions that we were asking for that 4-day period of time. And they also require providing backup power for critical loads. So demonstrating that adequate emergency power will be available. It does not specify whether that should be renewable or otherwise, and we don't necessarily either. I'm not going to go through the enterprise credits in as much depth, but they have very similar language and process. Again, the hazard and vulnerability assessment. Enterprise is primarily a multifamily or residential standard. So they have a strong emphasis on cultural and social resilience, which I think is great and something that we could certainly think about. And then access to potable water and resilient energy systems. So I'm going to switch over to the tool now and do the walkthrough. So I will do that here if you guys have any questions in the meantime or need a second to pull it up. So here is the tool that you were all sent, and this is the most recent version, but it's not necessarily the final version. There are certainly some issues that I've noted working through this, preparing for this session and making the slides and stuff. So any issues that you guys see on your ends, please let us know. And again, any additional resources or suggestions of things to consider, we're certainly open to. these are kind of living documents, so we're willing to be flexible with them. So on the first tab of the tool, you'll see the contents of each tab and a quick description of them, and then what the submission requirements will be for the B3 program. And for the first 3 stages of requirements, pre-design, design, and final design, we'll ask project teams to submit this workbook. So, all the information that is input in here will be the submission to the resilience guideline in the tracking tool. And then that closeout requirement would be the guide to the owner occupant if necessary. So getting into the tabs here, we'll look first at the vulnerability assessment. The tabs are ordered in the way that you can work through the process, and they link to each other in various ways. So I would recommend sticking with that order. Each tab has a more specific direction field up top here that I'm not going to go through because I'll just tell you guys, but those are there too, so you can view this. And a reminder that this is being recorded and you can certainly come back to it and reference it. So for the purposes of this demonstration, I'm going to loosely use a B3 project in Little Falls, Minnesota. So that's our project address here. And so that's the field you would type in, and then selecting the project county from our dropdown here. Many of the yellow fields have a little dropdown indicator here that you can select from. So then all of Minnesota's 87 counties are listed here. And that is in Morrison County, Little Falls. So you can see once the county is populated, some things have happened in the spreadsheet here. We can see that Morrison County does have a hazard mitigation and management plan approved. Unfortunately, it's not available online, so we can't look for it. Other counties do have them available. Some counties don't have it approved. For example, Nicollet County here is a draft status. So that's as of November of last year. I think I checked everything, and that will be something that periodically gets re-updated. But if the county you're selecting comes back as not available, it may be worth the Google on your end. But as of this publishing, all the ones that were available are linked in the spreadsheet here. We can also see the FEMA National Risk Index results that I had mentioned earlier. The National Risk Index rating is relatively low, and those are on the scale from very high to very low, described here. So the National Risk Index rating is a summation of the annual loss and the social vulnerability divided by the resilience. So it's a cumulative number based on these 3 variables, but not directly additive. So in this case, the community resilience in Morrison County is very high, and the social vulnerability and annual loss are relatively low, which all combines to a relatively low risk index value. So getting into the more specific natural hazard assessments, we see some of these fields populated here from the county dropdown and some not. So the yellow fields that are not populated are ones that we will have to work through. So we'll start with flooding here. This is this link describes the different options in this dropdown box of the FEMA flood zones: high risk, moderate risk, minimal risk, or no FEMA map available. There are some parts of the state where there's not a map available. And of course, we know these maps are out of date even now. So we're considering it, but it's not necessarily, if FEMA says no risk, it doesn't always mean no risk. And then this link over to the far right here is going to be the link to the flood zone maps themselves. So if you click that, it should open a browser window. And many, if not all of these linked websites are also location-based. So you'll enter your city or your project address to the level of specificity that you care to. And then, so in this case, let's see what we get here. we do have a map for this, the city of Little Falls in Morrison County, which we can view or print or download here via the FEMA flood map website. And this is a bit slow to load, so there's a lot of layers and stuff in it. So I will give that a second here. The next category of assessment is high wind, which you can see has multiple attributes, multiple data points to consider. Once again, we have a FEMA map here, a FEMA and NIST wind zone and max wind speed and extreme events. So we'll click that link here to get that input. So you can see from this NIST wind zone map that there are 3 different wind zones in Minnesota, 4, 3, and 2, and those are listed in the drop-down menu here. So we'll just look and see where in the state approximately we are. And I suspect we're between near St. Cloud for Little Falls. So I think we're going to be in zone 3 here. And certainly there are places that are on the border. So use your best judgment on that. So I'm going to put wind zone 3. And then for certain wind zones and wind speeds, there are requirements for storm shelters. So that's part of the reason we're looking at that. The next field down is the minimum design load wind speed for the 100-year mean recurrence interval. And that comes from this tool from ATC, the Applied Technology Council, which will provide us our wind and tornado data here. So once again, we'll type in the city. And then here we see the American Society of Civil Engineers design wind speeds. So the spreadsheet, if we recall, is asking for the minimum design load wind speed for 100-year mean recurrence interval, shown here. So using ASC 716 is the published year, so that's the most recent one. We'll click on MRI 100-year and see that for our site in Little Falls, we're in that 93 miles per hour design wind speed for the 100-year. So we'll just enter that here. And then you can see the next 3 fields are filled in already, and that is data from the Minnesota Hazard Mitigation Plan. So this windstorm vulnerability ranking is a scale from 1 to 87 for every county in the state. So 1 being the most vulnerable and 87 the least. So 20 is on the upper end relative to other counties in Minnesota. The number below is how many windstorm events per year have happened previously. And then below that is the expected windstorm events per year. So the hazard mitigation plan included some ideas about how events may increase or decrease across the state. So in cases such as this one, where there's an expected increase, that box turns this orange highlight color to draw attention to it. And you can see it's just a slight increase for these 2 events. So related to a lot of these high wind metrics are the tornado metrics. Minnesota is tornado prone. And as I said, we'll go back to the ATC tool there to get the design load wind speed for a tornado. And if that design wind speed is greater than 250 miles per hour, some project types will require a shelter. So that's what we're gonna just check here. So in this ATC tool here, we can see on the top tab, there are a couple different hazards, and we'll click over to tornado here. And we see that the design wind speed for our site is 200. And so for this stretch of Minnesota here, we do not need that storm shelter for certain project types, but we will enter that just as a reference. And then this FEMA tornado risk by tornado count and wind zone is a PDF document put out by FEMA about obviously tornado risk in the Midwest. And when I was going through this the other day, this link wasn't working, but I did find a new version of it that I will drop in the chat here. It looks like it was updated between last time I checked to now. So. And then there's that one. So you can see here, it's a couple page document. So it is a combination of the average number of tornadoes per year, which in this map we can see for the years listed in Minnesota, it was 26. And then so the frequency and the level of risk. So based on the number of tornadoes we had, which was on this map for our site, looks like, I'm looking right in this little orange section here of this map, 6 to 15. And then our wind zone, which we had already established was 3 from the previous one. So I'm not sure why this top scale has these breaks and this scale has these breaks down here. 6 to 15 puts us in between 2 categories, which I think is a flaw in the calculation. But for a level 3 or a 3 wind zone, in any case, it's high risk. So our level of risk for high wind events is high based on this calculation. So in this drop-down menu here, we would just select high risk. And similarly to above, the tornado vulnerability ranking is relative to other counties in the state, 1 most vulnerable and 87 least, and then historic tornado count and expected tornado count per year here expected to be the same. Moving into wildfire, we're going to reference a USDA/USFA wildfire hazard potential, and we're going to ask for the average rating within 5 miles. So that will be a map access through the ArcGIS web application here. So we'll open in Map Viewer, which is the web application. And once again, we will enter our address. And so this one, the metric is average within 5 miles, and there's not a great way to do it with this mapping application, unfortunately. So I like to try and get my map scale right around a mile here, and then use kind of a visual assessment of what a mile or a 5 mile radius would be. And for this site, there's a lot of variety. So I think it's trending towards moderate based on how much non-burnable area there is too. But for this site, this is one that I might want to download this information or open it in a GIS viewer and see if I could get a little bit tighter definition. In some parts of the state, it's very clear what the risk is. And in this one, this is a little less clear. You know, there's some parts where it's exclusively green or exclusively non-burnable. So I think for this site, I think I am going to go with a moderate risk based on the amount of yellow that was on that map. But that is, you know, tempered a bit by our drought rating here, which again comes from that Minnesota Hazard Mitigation Plan. It's the percent of time that was in a moderate or worse drought between 2000 and 2018. And there are 5 levels here. This is the second best rating, I guess. So drought is not much of a concern here, which kind of makes sense, I think, based on the river, you know, location and other things we've seen on the maps so far. And then once again, we have our vulnerability rankings from the Hazard Mitigation Plan, hailstorm vulnerability ranking relative to other counties, expected average events, and then expected events, and then the perceived winter storm risk based on that Minnesota Hazard Mitigation Plan is medium, and the potentials there are high, medium, and low. So moving a bit out of the kind of data-backed and pre-filled portions of this spreadsheet, there are also some man-made hazards that we're asking for consideration of. Things like an epidemic or pandemic, civil unrest, cyber attacks, infrastructure failures, major or minor fire, explosion, major accidents, and then air or water pollution, either sudden and severe or persistent and low level. So for these hazards, there's not as direct of a clear metric or ranking of them for the site. So we're asking project teams to have conversations about these and decide what a metric could be for their project, and then what the associated risk could be. So a common one that I've referenced in explaining this is for both fire or explosion, a metric could be, combustible materials stored on site. And then if the answer to that metric is 0, then the risk would be low. So something like epidemic or pandemic, the metric could be possibility of social distance workspaces or something, and the metric response could be, yes, we could do half capacity social distanced, and then so your risk becomes low of an epidemic shutting you down, again, depending on the hazard or the program of the building. And again, we're very open to resources or ideas about how to deal with these. We didn't want to ignore man-made hazards because there's not good data for it, but we weren't sure how to proceed, I guess. So after all of that hazard assessing, we then ask for project teams to take an idea, to think about the risk that all that stuff adds up to for the project. I'm going to check on our FEMA map here. Oops. Okay, now I'm choosing to. I'm going to skip that just in the interest of time. So for all of these natural hazards, we're asking that project teams roll up the different attributes, if they exist, into a simple risk rating. So for both high wind and tornado, I think that this project has a high to medium risk. And I think I would say high for wind and medium for tornado, just because of the relative ranking in the state, and the number of events per year is already over 1. So wildfire, I think also medium. Drought, I would say a low risk or no risk on that. And again, this is me going through this quickly. We would want this to happen with design teams and stakeholders and relevant parties and knowledge to the project. And then hail vulnerability. I think I'll put moderate for that one as well, or medium. And winter storm, because Minnesota thinks it's medium, I do too. So then after those risks are determined, the next thing to think about is what services could be impact if that were to happen, if that event were to come along. So because of how our electrical system is set up, I think high wind and tornado have the highest service impact to electricity for this project, I would say, and then structure and safety for the second, due to potential for damage to the building. For wildfire, the greatest risk to me, it seems to be structure and safety. And then for all of these hazards, the secondary service impact is optional. We're asking only for a risk and a primary to be identified. So the design team could work through all of those things and get to a filled out grid here, which would then inform these inputs in step 4, which are the services most likely to be disrupted and the highest priority hazard. So this is kind of the distillation of this whole page of the spreadsheet. Oh my God, we're so low on time. Sorry, guys. So I think for this case, for service most likely to be disrupted, I will say electricity and highest priority hazard. In this field, wind, including tornado, are combined. So because these two topics had the highest overall risk and high and medium between them, with similar impacts to electrical service and structure and safety, extreme wind, including tornado, is the appropriate hazard to identify here. All right, so moving into the second tab here, which is the project assessment. So we've been looking kind of broad, county level, site level, history, possible futures. We're going to look a little bit about the building itself here. So the initial project assessment asks for the building use, which in this case is an education center for adults. Oops. And then that ASCE building risk category is referenced in the next tab over here, this green indicated tab on the bottom, the ASCE 7 table. And this is a engineering classification of building types. The official definition is a categorization of buildings and other structures for, oh boy, for determination of flood, wind, snow, ice, and earthquake loads based on the risk associated with unacceptable performance. In practice, they're used by structural designers to determine the design pressures for structures and building components. The general theory is that a category 1 would fail before a 2 before a 3, and a 3 before a 4. For the purpose of this tool, we're just asking to quick identify that early in the process, and then to draw attention to the other risks associated that could be layered on top of this base risk. So our building, given that it is a relatively small education facility, is a level 2. Larger education facilities with high occupant loads would fall into a level 3. And then kind of emergency and shelter type structures are those that would be number 4. So back over to our project assessment tab here. Our ASCE building risk category is 2, and those are preloaded there. And then our intended service life, because it's a B3 project, is 50 years. We want to look a little bit about the population that would be served by this building to get an idea of what its role could be in a resilience operation. If something were to happen while the building was full, who would be there and what kind of things would they need to be safe? So the daily daily anticipated occupants, we'll say for this building, is perhaps 200 people. And then what percent of them might be elderly or youth? And that is, those two distinctions come from the data supporting those groups being the most vulnerable to hazards and least likely to recover from them. So those two factors also could influence the goal of the building for resilience, and then how the building might respond to and meet that goal. So because this is an education center for adults, it's unlikely that there would be a lot of youth there under 18, but there could be a higher percentage of an elderly population. And I'm doing this example as kind of a pre-design level assessment, but as the project progresses, we could expect that these numbers would get more solid. So I think I'll just put perhaps 15% elderly in the building for the consideration of that, and then 0 for youth. And then the last one in this population zooms back out to the census tract and takes a look at the CDC's social vulnerability index value. The CDC defines social vulnerability as the potential negative effects on communities caused by external stresses on human health, including natural or human-made hazards or disease outbreaks. The index value is determined by 15 census data points. So it's a singular rating, but it is backed by 15 different data points. And this link to the right here will open that website up to the mapping information. And then there's also background information about the tool and the data here on the left side. So we will type in our project here, Little Falls, Minnesota. And so the census tract that we are in here, there it looks like there are 2 in Little Falls, both with a moderate to high level of vulnerability from the CDC, which is slightly in contrast to what we saw from the FEMA rating of a low social vulnerability. So that text description is what will go into the tool for the traction. So low to moderate. Is that what I said? Or did I say high to moderate? Moderate to high. Moderate to high. All right, so all of that up till this point has been leading to the goal setting, which is kind of the meat of this spreadsheet buried here in the middle of the second page. And though the 3 current options for a resilient goal in this spreadsheet are shelter in place, and there's a little description that pops up on the blue box here, which is that the current occupants would be secured and supported for 4-day outage period. There's also the hub model, which we've been discussing, where you would the current occupants and potentially other ones from nearby would come. And then the last model is the evacuate and shut down, where the goal would be for people to be able to leave the building safely. And then the, sorry, I just saw a note in the chat. Thank you, Greg. The evacuate and shut down model would be that the building survives the physical damage, but doesn't need to operate with electricity or anything else to support people inside of it. So for our education center, I'm going to choose the shelter in place model based on its loads and neighborhood. So the next step is to identify which building services might be required to meet that resilient goal of sheltering in place. So for the goal of securing and supporting occupants, a crucial part for this building would be to make sure the cooling and heating services stay on. And then we'll say, because it's going to be continuously occupied, that perhaps food storage, including refrigeration, is crucial. So those two things and any other services will start to build out what that critical load profile looks like for the building, and any considerations of resilient power. Moving into the internal systems of the building, this is where we're starting to look at what the primary system for that building is, and then if there is a secondary or backup system being considered. So something like drinking water at this level at that stage of the project, we may know that our drinking water would come from a municipal source. And then we could think about a secondary system. If our municipal drinking water were to be cut off, how could we deal with that? And perhaps for this project, the best way to handle that would be to store potable water in the form of bottles or jugs or something. So just asking project teams to consider what their primary system is, and then what would happen if that system were to fail. And then the final portion of this, this page, which I was hoping to spend a lot of time on, but now I won't, is NREL's REAPT Light tool, which is a resilience assessment tool from NREL, obviously. And that requires a couple inputs, just basic ones. The site location, as always, and then a critical load factor, which can be rough, obviously, in this stage. For the multifamily building that Richard was showing earlier, which had that shelter in place model, the critical load factor was around 40 to 50%. So I think that is a good place to start for us here. Sorry, I thought this opened. It looks like it didn't. So on this NREL tool, there are a lot of questions and options to enter information, but to actually get a model out, you don't need a ton of stuff. But first of all, in step one, we're going to make sure we choose resilience as our focus, because that's what we're testing right now. Select your technologies for this building, PV and battery. You would enter the location, the land, roof space, electricity rate, if you know it, the specific one from the design team, it could be entered, or you can use a generic Minnesota one. And then a load profile would be required here. This site comes preloaded with some DOE reference buildings. So pick the program that is most similar to yours. And then if you have an idea about energy consumption, you can add it there. Otherwise, the program will generate a consumption based on the model, the DOE building model. And it's not clear to me what code level those are modeled to or anything, what kind of level that would be at. And then the last required information here is resilience, and that's the outage information. And that specifics for that are in the spreadsheet as well. So as I said, our critical load factor was between 40 and 50 for that shelter in place. So I'll say 45% here. Outage duration has to be 96 hours based on the spreadsheet requirements. Critical, we're going to auto select the start date here. And then through some movie magic here, I have the results from that building. If I were to actually, input everything based on our sample project. So these are the kinds of results you get. So first of all, the glaring thing you'll probably see is this negative potential life cycle savings. And that is because this simulation was optimized for resilience, not for financial. So this system is designed to meet the outage requirements, as we can see in this blue rectangle down here, but is not optimized for cost. So to meet our outage for this building, this is the PV size we would need, which translates to about like a 10,000 square foot array, and would provide about half of the building's electricity on an annual basis. And then there's some cool charts that show in an outage, which is the light blue rectangle here, how the demand shown by the dark black line would be met, either by battery serving the load, PV serving the load. And you can see before the outage where the grid would be and how that drops off in the gray. So you can play around with a lot of information there. And I pulled this just as this is what it looks like in the summer. This was a cool thing to see. You can see, sorry.
And Liz, did you see that there's a question in the chat about where did you get the critical load factor?
Oh, so for this example, it's based on the multifamily resilience building, or the multifamily building that you showed early as part of our initial study. So that energy modeling indicated that the critical load for that building for the shelter in place mode would be about 40 to 50%. So I extrapolated that to this building's shelter in place load. Thank you. Anyway, so this is what it looks like over a summer. And then the last thing I wanted to show on this NREL tool is the, if you were curious what the financial result, if you optimize for financial instead, what that would look like. And that's down here under resilience versus financial. So you can see that if this were optimized for a financial, the system would be less than half of the size and the battery would be quite a lot smaller, but it would have a positive net present value. So that's the last step in that page. And I want to get to the last one real quick here. And I'm so sorry we're going to run out of time. Should have made this longer. The last page here is the design strategies bank. So you can see in the blue boxes here that our selected high priority hazards and services are populated here. And those are for reference to filter down this strategy bank to what is most appropriate for your project. So using these little down arrows here, you can filter which hazards you're looking at. So I'm going to unselect all and then put back in extreme wind. And then you can see that that drops out the list to just these 4 strategies that are appropriate for responding to extreme wind risks. So then we would ask the design team to assess these and decide which one would be appropriate to pursue or to consider for the building. So because our risk was moderate, perhaps a commercial roof level certification from the fortified system is the best way to go for this project. And the metric and measured effect would be that roof related components and connections meet ASCE 7. So that strategy would be identified in this yellow bar up here, just again for reference, and then that's the end of the spreadsheet. So we would ask that design teams take those strategies identified via this and implement them into their design. And then we have some references here. This will continue to be built out as I add things, but all of the referenced strategies and stuff can be found here. So yeah, I apologize about the speed of that and that there's not a lot of time for discussion. If anybody, has last minute questions, happy to.
Well, and a couple things. I think, we should probably do a future second training that's all about digging into this tool. So, we'll look to schedule that as a follow-up. And then there's a bunch of questions in the Q&A, but one of the topics that, I think we mentioned it before is, talking about localized flooding maps and the importance of that. One of the, and we agree, we agree that localized flooding and having good maps for that is going to increasingly be a big challenge to solve in our building projects. One of the challenges that we have, and Liz mentioned it, is a lot of the things that we're kind of recommending for resilience, we had to go through and map what strategies are resilience plus sustainability in order to be able to put them into B3, because we only have statutory authority to do sustainability measures in B3, not resilience measures. So that's kind of challenge that we're navigating as we build this stuff out. So.
Yeah, I'm seeing some support for the training on the tool, and I think that's a great idea. And I think, yeah, moving into these being required is we'll definitely run it then and possibly before. So thanks for all the feedback on everything. It's going to help make the tool and the guidelines better.
One of the other questions that was in the Q&A was talking about the climate predictions and which prediction to use and how does that affect energy usage and flooding. And so we use the 8.5 out to 2040, which is I guess it depends on how you want to say it, the highest amount of climate shifting out to that period of time. The challenge is what's that good? Well, so there's multiple challenges with what climate prediction to use. One is, that's from the 5th assessment. When the 6th assessment comes out, supposedly the 5 prediction will become kind of the middle prediction. So that's, I think that's a whole discussion around this as an open question. In terms of what and how and what tools to use for some of these climate forward predictions. And I think there's additional research and work that needs to be done on that. And then I think we're at time, but there's one more question in the chat about another topic of discussion are these buildings as shelter in place and resilience hubs, and what are all the various shifts that need to occur for design requirements? For example, shifting from risk category 3 to 4 for public schools in these building types, and what would the cost be to do that for increased structure and things like that. And Laura's comment in the chat about if you have a resilience hub, what's its catchment area, and then how do you know that people can actually get there to be able to take part those services? I think that's what's interesting about this idea is the more you get into it, there are additional layers of things to figure out that should be part of a community resilience planning and neighborhood resilience planning, and these resilience hubs and having different building types be shelter in place. How does that get integrated into broader level plans? But again, we've faced the challenge of if we're upgrading the structure for resilience, that's additional cost for resilience, which may not have a direct payback. And how do we navigate all that in our B3 guidelines program becomes our challenge. So. And Liz, any kind of final housekeeping things about videos and all?
Feel free to reach out to Richard or I with questions. My email is on the screen here, and also with registration. So, and then if you use the tool and break it or find something weird, also let me know, please, because I'm kind of crowdsourcing the testing of that tool. So.
Well, thanks everybody, and definitely look for a second training in the near future. That's all about the tool.
Thanks everyone.
All right.